Okay, so this next section is all about blood pressure. So the first thing that we want to talk about is vocabulary. The first thing I have is what blood pressure is. So the definition of it, it's the force that blood exerts against a vessel wall. Okay, so it's the force of the blood itself pushing against the wall of the blood vessel. So it's always measured in millimeters of mercury. So Hg, I think I wrote this before, but just to make sure you guys have it. It's mercury is Hg is the symbol for mercury. Okay, so blood pressure. So now blood flow is the amount of blood flowing through a tissue in a given time. Okay, so milliliters per minute. And then perfusion, which we hit on the last set of slides. It's the rate of blood flow per given mass of tissue. So it's milliliters per minute per gram. So blood pressure is important so that our tissue stays perfused so that we get nutrients and oxygen to the tissue and we remove waste from the tissue. So it's interesting because in a normal person, total flow is constant and it's equal to the cardiac output. So your if you looked at one blood cell, in theory, it should flow from your right atrium all the way around and back to your right atrium in 1 minute. So flow should stay consistent and pressure should stay consistent. So we'll talk about that here in a minute. Okay, now studying blood pressure, the physiologists call it hemodynamics. So hemodynamics is like blood dynamics. So it's trying to understand how blood flows based on pressure and resistance. So there should be a little symbol right here. So flow is equal to the change in pressure divided by resistance. Okay, so this equation states that the greater the pressure difference between 2 points, the greater the flow. So if you turn on a garden hose really fast, right, it's going to blast the water out. So there's a great difference and the flow is fast. Now, the greater the resistance, the less the flow will be. So the longer the hose is, the more resistance you have, so your flow will be less. So we're going to talk about pressure and resistance and what can cause those in the body. Okay, so blood pressure. So you measure it at the brachial artery of your arm. Okay, so brachial artery. We use the brachial artery because you can put a blood pressure cuff around it and it's close to your heart. So it's a systemic artery that's close to your heart. You can get a blood pressure cuff around it. It's not invasive, so it's pretty straightforward. Okay, now blood pressure, everything gets moved around. Blood pressure, it's measured as systolic over diastolic, so S over D. Okay, so systolic is the top pressure. So remember what systole was again? So systole is when the ventricles contract, and diastole is when they relax. So what we're doing is we're measuring the highest pressure and we're dividing it by the lowest pressure. Okay, so S over D. You put the highest pressure is, here's an example of the highest pressure, and then here would be where the pressure is lower. And I have that all written out here. So systolic pressure, it's blood pressure during ventricular systole, and diastolic pressure is during ventricular diastole. So the normal value for a young adult, they say, is 120 over 75. That's like a normal blood pressure. So this would be the systolic and this would be the diastolic. This is an interesting example of what happens in your body. So in your arteries, the blood pressure is going to be much higher than it is in your veins. Okay, so one thing I want you to notice in this graph, the pressure fluctuates in arteries. Okay, so it's going from 80 to 120, 80 to 120, 80 to 120. So there's variation. Okay, this is due to the ventricles contracting and relaxing. So systolic is up here, diastolic is down here. arterial blood pressure is described as pulsatile, so it's pulsing, your heart is beating and relaxing, so it's pulsing. Okay, so and at one example to think about how the blood flows through the arteries in a horror movie, if like they cut somebody's arm off, okay, or I don't know, somehow somebody gets wounded and the blood is spurting, okay, so it's pulsing, it's like psh, it's squirting out one, a little bit at a time, okay, then they hit an artery. Okay, if they hit an artery, the blood would also be oxygen rich, so it should be really red too. Okay, now, as the blood travels, it hits the capillaries, okay, and at the capillaries, it slows down, right? The blood slows down in the capillaries so we can have more time for gas exchange, okay, and then it even slows down even further when it hits the veins, okay, so the pressure is really low, like 10, if we're lucky, 10 millimeters in the vein. Okay, now if they cut a vein in a movie, okay, the blood should just kind of ooze out. Okay, so it should be slow. It shouldn't be pulsatile. It shouldn't be pulsing. So the blood would also be darker red because it's oxygen poor. It could kind of be like on a purple tinge. Okay, now we can use blood pressure to get two numbers which are valuable. So the first number is called pulse pressure. So pulse pressure is really easy to come by. All you do is take the systolic and you subtract the diastolic. So like 120 minus 80. Okay, and that would give you 1 of 40. Okay, so basically it's the difference between systolic and diastolic. And what they are telling you is this is the amount of pressure on your arteries all the time. They use it because it measures the amount of stress on small arteries, and some people believe that pulse pressure is one of the most accurate indicators of heart disease risk. So what it's measuring is if your blood vessels are elastic. So if vessels are rigid, the systolic pressure is higher and the diastolic pressure is lower, and you end up with a higher pulse pressure. So that's the thing. Okay, so if your systolic pressure is 140 and your diastolic is 60, okay, then that increases it, right? So that would be, 40 and 40, that would be 80. So a number greater than 60 millimeters of mercury is high, so that means that your vessels are not in very good shape, so you are at risk for a heart attack. That's what one group thinks. Okay, now another important value that we can get from blood pressure is the mean arterial pressure. So mean arterial pressure, so it's the average of the blood pressure forces on the arteries. So if you could put something in your artery and you could measure the blood pressure and average it, that would be your mean arterial pressure. Okay, now you can use it to figure out if the tissue is being perfused. So basically, you want a mean arterial pressure between 70 and 110 so that you know blood is leaving the blood vessel and going into the tissue, and you're getting oxygen to your tissue. So the way that they calculate it is they take diastolic pressure plus 1/3 of your pulse pressure. Okay, and that's how you get your map. I'm not going to make you calculate it. I just want you to know, in theory, what it is, okay, and why it's useful. All right, now, some abnormalities of blood pressure. So the first one I have on here is hypertension. So hypertension is a chronic resting blood pressure of either 140 or higher or 90 or higher. Okay, so sometimes they just look at the top number or they just look at the bottom number. You don't have to have both numbers be bad. Okay, now, if your pressure is high, it's putting a lot of stress on the small arteries in your body. And this can cause arteriosclerosis. So it causes damage in your vessels. So I have a picture. Here's a picture where the vessel wall's been damaged, and then things start to stick to it. Plaque starts to stick to it. So the arterial walls start to get thick. It could weaken them and cause an aneurysm, which could cause a stroke too. Okay, now, if you get arteriosclerosis, your heart has to work harder because there's more afterload, so it's harder to pump the blood. Now, high blood pressure is, it could be caused by diet, can be caused by obesity, it can be caused by stress, and it can be hereditary. Every pound of fat that you add to your body adds an extra mile of blood vessels, so that increases your resistance and that increases your blood pressure. Now, one of the bad things is hypertension. It's called the silent killer because what happens is your blood pressure kind of gradually increases over time. So like it can be going on for 10 years and you don't even know about it. And so you'll have damage in your blood vessels before you even know you have high blood pressure. So it's important to get a physical. Okay, now down here I have aneurysm is a weakness in an artery wall. This is a really like extreme case because they're showing the abdominal aneurysm. But normally the wall is very firm and like a tube. But if you have an aneurysm, you can have a weakness in the vessel wall. And it just starts to bulge, which is not good. So that's aneurysm. And then over here, this is a picture. So here is a vessel that is pretty clogged up. It's blocked up. And what they do is they can do an angioplasty. So they'll put a balloon in, and the balloon will expand, and then they'll leave this stent in. And the stent is like a mesh tube that will keep the blood vessel open. Okay, so low blood pressure is hypotension. So it's chronic low resting blood pressure. They say lower than 90 for systolic or diastolic lower than 60. Now you have to remember some people always have low blood pressure, so it can vary from person to person. If you're an athlete, you're running all the time, okay, you probably have a lower blood pressure than somebody that doesn't. Hypertension could be caused by blood loss. So if you're hemorrhaging somewhere, or you're dehydrated, you're not drinking enough, or you're anemic and you don't have enough blood cells. So the symptoms of it include dizziness, fatigue, so you're tired, and they faint. Okay, now orthostatic hypotension is when you are laying down and you sit up and you get really, really, really dizzy. It can lead to fainting. So what's happening is the body, it has some homeostatic mechanisms that should tell your brain that you're sitting up and should compensate, but it's not happening fast enough. So we'll talk about that and try to make it make sense.